So what we're going to talk about here are solving inequalities. So when solving an inequality, we're going to be interested in two things. Okay, we're going to be interested in two things. We're going to be interested where the function is equal to 0 and where the function is undefined. Everybody okay with that? Now, if I look at this first problem, this function that we're given is a polynomial, right? In general, polynomial. It's quadratic, more specifically. But polynomial is the key, because what do I know about polynomials? Well, they're never undefined. So the only thing I need to worry about is when it's equal to 0. So that's what I'm going to be worried about solving. Well, that's easy, right? I can just factor this, as Joey had said. So I get 2 and negative 2. Now, keep in mind, I'm not solving an equation. I want to solve an inequality. There's going to be infinitely many answers to almost any inequality. So to sort that out, to be able to write my intervals that represent my answers, what I'm going to do is I'm going to draw something called a sign diagram. So I'm just kind of drawing a number line, and I'm going to put my zeros on the number line. Now, because this is a strict greater than inequality, I know that negative 2 and positive 2 are not actually going to be solutions for this inequality, right? Because if I plug either negative 2 or positive 2 in, x minus 4 is equal to 0, and 0 is not greater than 0. Everybody's okay with that? So I'm going to write open circles there as opposed to like a filled in circle. And then what I'm going to do is pick some test values. So maybe negative 3, 0, and 3. I'm going to pick a test value for like each section of my number line, right? The zeros or things that are undefined are going to like divide up my number line into a bunch of sections. I'm going to pick one test value from each section. The value I pick as my test value doesn't matter as long as that value lives in that section. So to the left, anything less than negative 3 or negative 2 would have been fine. I'm just going to pick negative 3. Anything between negative 2 and 2 would be fine for section 2. I picked 0. Anything bigger than 2 would be fine for section 3. I'm just going to pick 3. Cool? Now I'm going to plug those test values into x squared minus 4. So if I do negative 3 squared minus 4, that gives me 5, right? That's greater than 0. So this interval from negative infinity to negative 2 is one of my answers. If I plug in 0, 0 squared minus 4 is negative 4. That is not greater than 0. So that does not contribute to my answer. And then if I take my last one, I do 3 squared minus 4. Well, that's 5. That's greater than 0. So that section contributes to my answer. And I'm done. So far, so good. Let's do another example. All we're doing today is just examples of doing this process. So we're going to start off with some polynomial examples, and then we'll work our way through some more complicated function examples. But that's the gist of it. Like if you get the sign diagram process, we should be okay. So first thing I'm going to do is look at what kind of function I have here. It's a polynomial though, right? So all I care about is where it's equal to 0 because it's never undefined. And Joey's right. He said, okay, I'm going to try to factor this polynomial to solve it. So I'm going to take out an x to start. And then if I look at x squared minus 4x plus 4, that factors as well, correct? What does that factor to? X minus 2 and x minus 2. So when I solve this, I get 0 and 2 and 2, but I don't really need to write the second 2. Everybody's okay with that? Just once is enough. Okay, so I'm going to draw my number line. On my number line, I'm going to have 0 and 2. Now, if I plug 0 in for x, I'm going to get 0, and that is less than or equal to 0, right? So here I'm going to use a filled-in circle. If I plug 2 in to my polynomial, I'm going to get 0, and 0 is less than or equal to 0. So again, I'm going to put a filled circle there as well. Now I'm going to pick a test value for this first section. So maybe -1. And then we'll pick a test value for this section. Oops. Say 1. And then pick a test value for the third section, say 3. Feels okay? When I plug -1 in, I'm going to get -1 times -3 times -3. So that's going to be -9. Well, -9 is less than 0. So I know my answer goes -infinity to 0. Now, why did I use a bracket here on the 0 rather than a parenthesis? Because I used the closed circle at 0. Exactly right. Very good. If I plug 1 in, I'm going to get 1 times -1 times -1. That's just 1. That's positive. That's not less than 0, so I don't want that section. And if I plug 3 in, I'm going to get 3 times 1 times 1. That's also positive. I don't want that section, but I do want still 2, because 2 is still an answer. So the way I'm going to write that is I'm going to do that union symbol, and then I'm going to do the squiggle brackets with just the number 2 in. So that's a little trick that can happen, right? If you can have like one piece of the boundary of your interval that you want, but no interval on either side of it. In that case, you just use like a union and then the squiggly brackets and just list the number. Is that okay? Okay. Next example. I think I have 4 total examples. Don't quote me on that. There might be a 5th one hiding out back there. Nope, just 4. All right. So what's different about this problem than the previous ones? It's a fraction. It's a rational function, right? Rational functions can be undefined, and they can equal 0. So we're interested in 2 things, right? When is a rational function undefined? When the denominator is equal to 0. And then where it's equal to 0, when can that happen? Think back to graphing. How do we find those x-intercepts? We set the numerator equal to 0. Everybody's okay there? Okay. Now, the -1 is undefined, right? Anything that's undefined is always going to be an open circle. But the 4, when I plug 4 in, I get 0, which is greater than or equal to 0. So 4 is going to get a filled in circle. So your zeros could be open, they could be closed. It depends on whether it's a or equal to inequality or not. The undefined pieces always are open. Joe.
What if it was the sign was split?
If it was less than or equal to 0, 4 is still an answer because 0 is still less than or equal to 0. Because when I plugged 4 in, I would still get 0, right? Even if it was less than or equal to, it doesn't matter. Cool? Okay. So we'll go ahead and pick some test values then for each of my sections. Bless you, bless you. Everybody okay with those test values? When I plug -2 in, I'm going to get -6 over -1. That's positive. That works. When I plug 0 in, I'm going to get -4 over 1. That's negative. That don't work. When I plug 5 in, I get 1 over 6. That's positive. That works. Notice I'm using a bracket there on the 4 because I have the filled in circle. Everybody feel pretty good there? Overall, how's this going? It's not bad, right? Okay. Last example's the most confusing one, or the most difficult one. All right, take a look at this example because you have a lot going on here. What do you notice here in our example? I have a square root, an absolute value, and a fraction, right? It's a lot going on, right? Okay, let's start by worrying about the undefined parts. What parts can make this undefined? So if the denominator is 0, everybody's okay there? And where else? If the stuff under the radical is negative. Everybody's okay there? So how do I solve the absolute value of x minus 1 is equal to 0? How do I get rid of the absolute values there so I can solve this? Nope. We break it into two equations where you just take the right-hand side left alone, and then you negate the right-hand side. What's nice about 0, though? Can't be, it's just still 0, even if I negate it, right? So this is just going to come out to be one answer, just x equals 1. Is that okay? So if I do this one, if I subtract 4 from both sides, I get x is less than 4, right? So that tells me anything where I'm less than 4 is undefined. So I have to remember that when I'm picking my test values, that I can't pick anything less than -4, right? All right, but this doesn't actually contribute because it's not an equal sign. It's an inequality instead. But I do need to kind of be mindful about making sure when I'm choosing my test values, not doing anything less than -4. So because it's a fraction, I know it's equal to 0 when the numerator is 0. So how do I solve the square root of x plus 4 equal to 0? Square both sides. Now's time for that. What's 0 squared? And then we just subtract the 4 over, and there's that. It does make life pretty pretty easy, right? Like anytime we get lots of zeros popping up, it's like, yes, sir, like that. Okay. Now, the -4, should that get an open or closed circle? Open. Can you tell? The zeros are always going to depend on the type of inequality we have, because this is not a or equal to inequality. I know that all my zeros are going to be open circles. The things that are undefined always are open circles. Cool? All right, let's pick some test values. So I have, let's pick -4, 0, and 2. Did you guys see any issues here? Yes, very good. What's that telling me? Just like nothing over there is going to be part of an answer, because it's undefined over there all the time. Everything over there is undefined. I don't care about it. Cool? Well, that's nice. It saves me like one more less thing to plug in, right? So if I plug 0 in, I'm going to get the square root of 4, or 2, over the absolute value of -1, which is 1. That's positive, so that's part of my answer. Cool there. If I plug 2 in, that's going to be square root of 6 over absolute value of 1, which is just 1, also positive. And I should be good. Yes, sir. That was what that got me, was knowing that all that stuff over there is just junk.
Why is it undefined?
Because if I plug in -5, I would end up with the square root of -1. Or if I plugged in -6, I'd have the square root of -2. If I plugged in -4.000000001, I have the square root of -0.0000001. All those things are undefined. Everything over there is going to be undefined. It's not just that I picked a bad test value. It's every test value over there is junk.
And why did you use that symbol instead of
Why did I pick less than 0? Because I know that anything under a radical is undefined if it's negative.
Okay.
Right? So if I took the stuff under the radical and I said, okay, the stuff that's undefined is the negative, so what stuff don't I need? That stuff. Does that make sense? Okay, that's the gist of it. Again, the process, relatively computationally easy, right? Just kind of sorting out what's going on in an organized way can be the tricky part. But this is it. That's the last thing for this chapter. Whoa. Yeah, the whole chapter. So you guys, that's 35 through 56. That seems like a lot though, right?
Oh, yeah.
Let's just do that.
Hey, thank you.
Do the odds. That's fine. So when you come back from break, what haven't we done for chapter 14 yet? What should you expect the day you come back from break? Homework quiz. What else are we going to do?
A test.
Well, the test review. So the half sheet will be due on that same day.
Yeah.
And then the following class would be the test.
So that's the day we get back from break?
The half sheet will be due on.
Let me just get you some days here. Let me look at the calendar.
Maybe no, you're not. You need to be like in the strengths.
No, I need to go to the mall.
No.
Okay.
Saturday's the 8th.
Okay, perfect.
67 is the 10th.
So much money.
Yeah, I know. I don't even know how you do that.
So there you go. So the 8th, that's Monday. That's the day we get back. That's the homework quiz, half sheet review. Wednesday, the test.
I really can't trust this.
Yep.
My grade went up 12% out, which the RNA does.
I'd like it on Monday, preferably. Yeah. So let's figure out what's due when. Shh.
Amino acid RNA complex to do translation. What's happening at
That's so fun. I know I have to do the peptide one, small protein
All right. So for this Sunday, what is this? What is this Sunday? The 31st. You have 25 through 32. That was what we assigned last time. We'll have this 35 to 55 odds. And then we have the delta math. But I'll tell you a secret. Yeah, I wouldn't look at any homework until the 7th. Right? Just so you know. Now, if you're going somewhere after Easter, I might want to have all my somethings wrapped up before I get on a plane and go somewhere. So I don't like waste my vacation doing math homework.
Me on the air doing the math homework.
Not wasting.
No?
I'm just saying, if I were you, I'd want to have all that stuff wrapped up so I didn't have to think about it.
Changes all amino acids. So translation different and area rates plus